So now I will present the discrete problem. The discrete problem is find u in the superleaf space solving this equation with the estimation for 2. So the discrete problem with the condition, the sum of f on all the mesh it's equal to 0. The result is there in the theorem for 1, 0 there. If p belongs to 1 to infinite, there exists constant such that for the function f finishing on a boundary of Rh and satisfy the condition 4, 5, we can find u in superleaf space solving the equation, the discrete equation for 3. This lemma will give us the weak formulation for the solution. So if f in L2 finishing on boundary of Rh and satisfying the equation, the condition 4, 5. So for you in superleaf space, solve the equation. If and only if we find the phi function in L2 and the sum of f AHBK times phi IHBK, we can write it so that, and we use the condition. For the condition, we can write the left side of the equation on 5.1 as f AHBK at the sum phi AHBK minus phi 0, 0. So for calculate the sum f AHBK phi AHBK minus 0, 0, we have to choose the path between a, the point AH and BK, and 0, 0. After the calculate, we can find this result. Which I VH, it's equal H sur on 2 I between A L minus 1 when A between A and L minus 1 minus H on 2 if the sum if IHBK if the A between minus L plus 1 and 0 and HBK in the same way. On the other hand, we can calculate VK and W and WK.
Sorry, can you I cannot realize the main problem here, the main result. You can come back with the main result. You cannot follow this. The main result of this. Can you explain this?
So, I search for you in Sokolov espace, solving the problem, the discrete problem, the equation 4-3 with the estimation. And we have the condition, the sum of FH BK est égal à 0. So, depending of this condition, I can write the sum of FAH BK phi IH BK such that phi IH BK time phi IH BK minus phi 0. So for find this sum, I have to choose the path between 2 points. RH for chaque corner, because I defined the RH southwest, southwest, and northeast. For chaque corner, I find the path. Okay. So when I find the path, we can find this such that, but VH and WH, VK and WK is defined such that. We can find this, the same results for the back forward. So, the calculus it's very long. Yeah. It's just it's the point of the path between 2 points. So this corollary, it's the solution of the equation, discrete equation with u it's equal 0 on the boundary of RHK. U1 it's defined as the sum between VH and WH, and 0 if it's on the boundary, and U2 it's the sum of between VK and WK. So the conclusion explicit of how the obtained to solve the equation in interior the RHK, we provide a direct proof of the discrete inf-sup condition for the max scheme. This proof which not go through the continuous problem.
So it is a new proof.
Without use the continuous proof, because all of the persons they working on this problem, they use the continuous condition for prove the discrete problem.
So you have given the condition on the function f, second term, right hand side. Mm-hmm. On f, you said that the integral of f is equal to 0.
No.
If you drop this,
no. I changed the condition. It's the result of Brzezinski. The integral is equal to 0. I take the sum of fx, fahbk, the sum on the degree, it's equal to 0. I use this condition. I don't use the integral.
You didn't use the space L0.
Yes.
L20.
L20. Yeah, but it's not. It's the space discrete. It's not the space integral. So I use this condition. It's not this one. This one. Yeah. That integral of 0 for this theorem. It's not. It's one that one is the continuous. So I used this one for the discrete, the condition.
What can we deduce from the inequality estimation for what can we deduce? The uniqueness of the solution or what? Is an energy estimate.
I prove it. I forget it for the presentation. Yeah, it's the estimation on the Sobolev space. Yeah, I proved it in the paper.
It gives you the uniqueness of the solution or what?
Yeah, the solution. Of course. The norm. The norm on the Sobolev space.
Condition 4.5, it's not almost the same, integral equals to 0, but in discrete form.
Yeah, almost 0. The sum, huh?
Yeah, I mean, it's
not.
It's the same, almost the same, I would say.
Yeah.
I mean, when you take 4.5, this means with the grid that you took, with the mesh that you took, this means the integral equals to 0.
Yeah,
Integral of
it's equivalence, but it's not the integral.
No, I mean, in your situation, it's the integral.
I have a question.
If you do the comparison between the continuous and the discrete, yeah.
Regarding this discrete problem, okay, you have presented that it is possible to solve this discrete problem, but you have this inequality which seems to be nice. This estimation for 4, the natural question is, how can I go far? I mean, for which, what will be the solution of the limit when I take h, k goes to 0? I will obtain maybe some inequality which is different. What will be the limiting solution? You have found now a discrete solution, okay? Given the grid, you have some solutions. You have a family of solutions.
Yeah.
Okay, when you take the meshes or the scale goes to 0, when the space will be full,
Okay.
what will be the limit? Can we recover the classical result by Brzezinski or not?
It should be the solution of
I-
the continuous case.
I
And
think.
under what conditions?
I think, but I'm not sure. I don't finish the papers, huh? It's not finished yet, but I think, yeah. I'm not sure.
The estimate 4.4, the constant C, I think is independent of M and L. The constant C in the
Yeah,
inequality.
it's independent.
So
It's
we can
independent.
go by limit.
Yeah, it's independent.
Yes.
Yeah.
Exactly. For this reason, I
Yeah.
said this is an interesting estimation.
Constant C is independent of N and L, M and L.
Yeah, the C it's independent.
Yes. So you can go by limit.
I think.
Yes.
I'm not sure.
You can go to the limit. If the limit exists, first you should prove
Yeah.
the existence of the limit.
If
and
F
then you go.
converge, if Fn converge to some function, so
If-
U converge by this inequality. No problem.
Why this limit problem is important? Because once you can go to to a solution in a limit, this means that once you have problem to get explicit solutions or to solve the original problem, you can approximate. This is the powerful of the result. Once this is possible, of course.
I think it's possible. I can find it, but I don't finished yet.
Thank you very much.
I-
just try to finish. Oh, yes.
Yeah, I heard a problem there. between H and K, I don't know if I can develop this condition or not. I don't know yet. There is another point for me. It's not very strong for the solution. The condition is comparable the two H and K. It's really confused. I don't know yet. But the solution is depend of this condition.
Is this constant C the constant appearing in the inequality?
Yes.
Huh?
Yes.